Very good morning to all of you. I think so my sound is clear. Okay. So in previous lecture, yesterday we have seen the example on uh, your pipe flow problem. That is circular pipe in series, and then we have seen the what is the effect of your pipe in series and pipe in parallel. That also we have seen. Okay, this is pipe in parallel, this one is pipe in series. So its effect on the discharge and the friction factor we have seen, or you can say the head losses we have seen yesterday. Also, we have solved one problem on this parallel connection in the pipe flow problem. Okay, the parallel system we have seen on example, and before that we have seen the series example earlier. The first example was of the series connection, and second example we saw the theory of series and parallel connection. So, example on parallel we have seen, and Q1 and Q2 we will find out by drawing the by drawing uh, energy period with line. Okay. Today we will see the outcome of today's lecture is we will understand what is the Dupits equation, Dupits equation, and simultaneously for Dupits equation you should uh, understand the concept of equivalent pipe. Concept of equivalent pipe. So this Dupits equation is based on it is based on a equivalent pipe. Equivalent pipe concept. Okay, so that's why this is the outcome of today's lecture. So that's why we should know what is the equivalent pipe, and if type permit, we will see introduction to siphon. Introduction to siphon. So in pipe flow, it is very important to know what is siphon. Okay. So this we will see in today's lecture, the pipe permit. Then we will see the pipe networks also. Okay. Okay. Or otherwise, we will see up to the introduction of siphon. Just once again, the student should know. So today is the 42th of lecture and 41 already covered. Okay. So what is the Dupuits equation? For that we will see the equivalent concept of equivalent 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 five equivalent five. Okay. So why the equivalent pipe meaning? Mostly a compound pipe consisting of several pipes of varying diameter and length to be replaced by a pipe of uniform diameter, which is known as equivalent pipe. Okay. So what is the concept? After lecture, what is the concept? Concept is that most of time there are the compound pipe consisting of several pipes where with a flow with varying diameter and varying length. Okay? And for that varying diameter compound system, many pipes are there. We will convert into a single pipe system. Okay, only a single pipe system with uniform pipe diameter and length. So that is nothing but the concept of equivalent pipe. So you can write down the definition also. So In the most of the cases, the compound pipe consisting of several pipes. So you can write down mostly in the pipe flow problem, compound compound pipe consisting of consisting of consisting of several pipes, several pipes, several pipes of varying diameter, of several pipes of varying diameter, varying diameter and and length, and hence is to be replaced by is to be replaced by is to be replaced by a pipe of uniform diameter, pipe of uniform diameter, uniform diameter, which is known as which is known as equivalent pipe, which is known as equivalent pipe, more than equivalent pipe. Okay. So you know that in pipe flow problem, if there is different reservoirs, okay, so many pipes they are coming having a different diameter, okay, different diameter, okay, and if you convert it into uh, uniform diameter single pipe. So these many pipes are having a diameter D1, D2, D3, D4, and we convert into a single uniform diameter D. So that is the concept of equivalent pipe system. That is the concept of equivalent pipe system. Okay. So students, they are joining late. I request they should join on time. Okay. So this is the equivalent pipe system. So T1, L1, here, T2, L2, T3, T4, and 4. Okay. So if you convert the all this diameter pipe into a uniform single diameter pipe, this is nothing but the concept of your equivalent pipe system. Okay. So if I will if uniform diameter of equivalent pipe is known as the equivalent diameter of the compound pipe, the size of equivalent pipe may be determined by the following procedure. So if you will write then L1, L2, L3, etc. are length of length and D1, D2, D3, etc. are the diameter are the diameter. अरे बेटा लेक्चर चल रहा है लेक्चर में आप चालू होकर रहेंगे if L1, L2, L3, etc. and length L1, L2, and D3, etc. are the diameters, are the diameters, are the diameters representing, are the diameters respectively, respectively, that is representing the diameter of pipe 1 D1, D2 represents the diameter of pipe D2, and D3 represents the diameter of pipe D3, pipe 3, and the length L3 of the different pipe of the different pipes okay, of a compound pipeline, of a compound pipeline, compound pipeline. So many pipelines are connected with that. Then we need to pipeline. The total head loss in the compound pipeline, the total head loss in the compound pipeline, compound pipeline. Neglecting the minor losses, neglecting the minor losses, minor losses due to flow is HL is equal to F1 L1 V1 square upon 2G into D1 plus F2 L2 V2 square upon 2G into D2 plus F3 L3 V3 square upon 2G into D3 plus so on. How many pipes or compound pipe system are with you? Okay. Now we know from the continuity equation, from the continuity equation, we know that the Q is equal to A1 V1 is equal to A2 V2 is equal to A3 V3. Okay, assuming F1 is equal to F2 is equal to F3 equal to dash 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 F is the friction factor. You know, is the friction factors for the compound pipeline system. Okay, so we know that. So if I will write down in terms of V1 square, it is Q square upon pi by 4 into T1 raised to 4. Okay. So if you know that if I will put this value in HL, what will be the formula? F into Q is 2 is Q square upon pi by 4 square into 2G into D1 raised to 5 and L1 square. Okay. Similarly, if you write down the flow is F2, FQ square, array HL2, FQ square L2 upon pi by 4 whole square 2G into D2 raised to 5. And similarly, so on. How many compound wall system is there? I will say this equation number 1. And if I will take a common terms out that F into Q square upon pi by 4 square into 2G, this we will take the common. So what will be the HL formula? It will be L1 upon D1 raised to pi plus L2 upon D2 raised to 5 plus L3 upon D3 raised to 5 and plus so on. And this is nothing but I will say the equation number 1. Now if I will say if D is the diameter, if D is the diameter and L is the length of the equivalent pipe, so I will change this compound pipe system into the equivalent pipe only of having a uniform diameter D and then L. Then, then, then it would carry would carry the same discharge, the same discharge Q, same discharge Q, same discharge Q, if the head loss, the head loss, the head loss due to friction, the minor losses we are neglecting. Due to friction, in the equivalent pipe will be pipe. The loss of head of friction in the equivalent pipe will be HL is equal to FL V square upon 2GD, and if you put the V value, it will be F F L F this. We know that V is equal to Q upon A. So V square F Q square upon A is nothing but pi by 4 T square. So if I write on this, so pi by 4 square into 2G into T raised to, this will be 4 एरिया स्क्वायर अगर मैं करूंगा तो ये डी रेज़ टू पावर 4 हो जाएगा ना, 4 into and this one d, it will be 5 because the product of exponential is added. Okay, so d raised to 4 into d raised to 1, it will be d raised to 4 plus 1, it is d raised to 5 for exponents. So it will be the metal ion will be written as FQ square upon pi by 4 square into 2G in bracket L1 T1 raised to 5 plus L2 J2 raised to 5. So here it will be this, no? Then if you equate this, then plus dash. अब ये दोनों को हम इक्वेट करते हैं तो what will be the, because equating equation 1 and 2, this is equation number 2 and this is 1. Equating equation number 1 and 2, equating equation 1 and 2, what happen? The common terms will get cancelled. The common terms will get cancelled and it will be remain L by d to the power 5 is equal to L1 d1 raised to 5 plus L2 d2 raised to 5 plus L3 d3 raised to 5 plus so on. Okay, this is equation number 3. So you know that this equation number 3 is known as Dupits equation. And which may be used to determine the size of equivalent pipe, size of equivalent pipe, size of the, okay. which may be used to determine the size of equivalent pipe. So this Dupits equation is based on the equivalent pipe system. Okay, so that is nothing but this one is nothing but uh, this equation is nothing but the Dupits equation. Equation three is nothing but Dupits equation of the pipe flow problem. Pipe flow problem. So that is nothing but this. Okay. So if in example it is asked the derivation Griffith's equation, then you have to start from this, from the equivalent pipe system, from here, concept of the, from this definition you will start and then you will come to the solution, this equation and this. और अगर एग्जाम में इक्विवेलेंट पाइप सिस्टम पूछा तो दैट इज नथिंग बट दैट इज दिस सिचुएशन so to derive this and say that this is the equivalent pipe system. Okay, I think so आपको यहाँ तक समझ में आ गया होगा. Now the introduction to siphon. Introduction to siphon. तो सिफॉन पाइप आपको मालूम है कि नेगेटिव प्रेशर डेवलप करके फ्लो स्टार्ट करना फ्रॉम द डिफरेंट लेवल ऑफ द पाइप सिस्टम. तो अगर मैं इस तरह का फिगर अगर बनाता हूँ, दिस इज योर फिगर Y1, दिस इज Y2, ओके, दिस इज द लेवल, this is Z1 from the bottom, this is the bottom, okay. So this level is Z1 at this point 1, and then point 2 somewhere here. The pipe is like this, connected with two reservoir into the embankment, and at the center, and this Z2 from the bottom, and here some level 3 from the reservoir 3, and this one is Z3 from the bottom. And when you draw the HGL line, the HGL line will be the line of pressures, and it will be like that. The HGL hydraulic current line. Hydraulic current. And this above this hydraulic current line, okay, change the color. Can you understand this? This portion above the hydraulic current line, this is nothing but called as siphon. Why siphon? Because the negative pressure is developed above the hydraulic current line. So in this system, when we say the siphon is developed, the siphon is developed above the hydraulic current line. So if a part length of a pipeline has its central line above hydraulic current line, if a part of pipeline has its central line above the hydraulic gradient line, that's HGL, then at its summit, then at summit at point two in above figure, then will be there will be there will be negative pressure. There will be negative pressure, negative pressure, and this negative pressure and this negative pressure should not be less than should not be less than should not be less than vapor pressure. Vapor pressure should not be less than vapor pressure. Otherwise, it may occur. May occur. It may occur cavitation at summit. Cavitation at summit. At summit of the pipe. Of the pipe, and it may suffer a damage. And it may suffer a damage. तो जनरली सिफोन आप देखें, सिफोन हम लोग जब आपका रिजर्वायर और दूसरा रिजर्वायर इसमें हमको वाटर कोई भी ट्रांसफर करते हैं, इनके बीच में कोई ऑब्स्ट्रक्शन आ जाता है ना। आप लोग देखते होंगे कि ड्रम के अंदर आपको पानी निकालना है बकेट में, ये आपका ड्रम है, ये वाटर लेवल है, और आपको पानी निकालना है कोई पैन नहीं ना, तो वी नीड अ पाइप transfer of water. Okay, and this should be submerged into the water deep. Okay, and then what we will do? We will create a negative pressure, and then the pipe will flow over this summit. And this is nothing but this area. It is nothing but it is under the siphon action. लेकिन अगर ये सिफॉन में जो प्रेशर है, नेगेटिव प्रेशर अगर वेपर प्रेशर से कम नहीं अगर रहा, तो व्हाट हैपन, द कैविटेशन विल फॉर्म इन द नेगेटिव प्रेशर पाइप एंड दैट विल डैमेज द पाइप, so that is the, and flow may become discontinuous, and flow may become discontinuous, और फ्लो भी कैविटेशन फॉर्म होने के वजह से फ्लो भी आपका रुक जाएगा। हेंस दैट इज P2 upon gamma should be less than वेपर प्रेशर से कम रहना चाहिए to continue the flow and siphon action, and which is the vapor pressure, which is minus 7.6 meter of gauge pressure or plus 2.7 of the absolute pressure. This is the vapor pressure. And if you apply the Bernoulli's theorem, for this type of problem, between 1 and 2, that is, so it will be Z1 at the state pressure is 0, that is also 0, is equal to P2 upon gamma plus Z2 plus V2 square upon 2G plus HF from 1 to 2, it loss from 1 to 2. So this P2 upon gamma क्या रहना चाहिए आपको, that will be Z1 minus Z2 minus V2 square upon 2G minus this head loss from 1 to 2 section. So this is nothing but the introduction of concept of siphon. So we will stop here because I have taken the oral examination for the class student. Continue tomorrow. Lecture is there on practical. So thank you for joining. If you any doubt, you can write to me. I will after the oral I will take. Okay. We have seen only this 5 network not able to see today. We will see.